Hello again, guys. This is another day of geometry here. Yesterday, we kind of finished up with the concept of an angle of elevation and how that applies to applications of SOHCAHTOA. And again, angle of elevation. Again, this is the problem we left off with. These are the notes from yesterday, so we can just pick up where we left off there. This one talked about max in a boat and a lighthouse. And again, angle of elevation has to be made with this horizontal line, and it's looking up from that horizontal line. That's that 27 degrees right there is your angle of elevation. So we're going to pick up with that same day of notes, basically, and I split it into 2 days. And if you look further onto the notes, along with the angle of elevation, there's something called the angle of depression. So the angle of depression is an angle made with a horizontal again. So angle made from a, just like yesterday, horizontal line. But now, instead of looking up, you're going to be looking down. I'll show you what that looks like. So again, the important words here are horizontal line. It has to be made from a horizontal line, and it has to be looking down. So on this picture down here, to illustrate an angle of elevation, now instead of being from the person on the ground here, you're going to be up here on top of the building. Now it has to be looking down at the person on the ground. So again, that would be this person looking down on that person right there. Now this angle needs to be made with a horizontal line, like I said before. So in order to do that, I have to make a horizontal line coming off the top of this building. So that creates then your angle of depression, which is located right here. And again, it's looking down from that horizontal line. So this right here is your angle of depression. It is often confused incorrectly with this angle in here, and this is not, again, if I make a dot right there, it's often confused with that angle right in there, but that is not the angle of depression because it's not made with a horizontal line, that's made with a vertical line. So that is not the angle of depression, this one is. Also, notice something about the angle of depression is that, again, this horizontal line up here is going to be parallel with this horizontal line down here. And what that creates, if I use this line right here as the transversal, it creates alternate interior angles. So the angle of depression here is going to be congruent to this angle here, which is actually the angle of elevation up to the top of the building. So it's in the same problem. Again, the angle of depression and angle of elevation are going to be alternate interior angles, which means they're going to be congruent. Alright, so let's look at an example of an angle of depression. So it's Max again. So now Max is in a helicopter and he sees a car on the road below. So I'll try my artistic talents here. So I need a helicopter, something like this. Not a bad helicopter. So we got a helicopter and then a car on the ground. So let's see, a car. Something like that. We'll put some wheels on it. So let's see. So Max is in a helicopter and sees a car on the road below. The angle of depression to the car is 42 degrees, and the altitude of the helicopter is 50 feet. How far on the ground is the helicopter from the car? So what's the distance on the ground? So let's see what's going on here. So first of all, this car is on the ground, which again makes a horizontal line. Something like that. So there's the ground. And it talks about the angle of depression from the helicopter. So again, it has to be made with a horizontal line. So a horizontal line looking straight out of the front of the helicopter would be that. The angle of depression would be made with that horizontal line looking at the car down on the ground. So again, that measure of that angle, let's see, is 42 degrees. So 42 degrees. And what else do I know? I know the height of or the altitude of the helicopter is 50 feet. So that would be this distance here. That's how high the helicopter is off the ground. So this is 50 feet. Let's figure out what they want to know now. So now it wants to know how far on the ground is the helicopter. Oh, so how far on the ground would be this distance down here. So they want to know how far the helicopter is on the ground from that car. So my right angle would be here. This 42 feet, remember it's alternate interior with the angle of elevation from the car to the helicopter. So that means that this is also a 42-degree angle right here because of alternate interior angles. So this is also 42. So you can see your triangle right now. Here's the right angle. These are the two legs here. This would make up the hypotenuse. So now let's try to figure out what the sides I have in regard to the angle. The angle I have is this 42-degree alternate interior angle. This would be opposite that angle. This would be adjacent to that angle. So again, because I have O and A, I choose to use TOA from SOHCAHTOA. So again, the T in TOA stands for tangent, so I do tangent. The angle I have is this 42-degree angle. It's going to equal the opposite side, which is 50, over the adjacent side, which is what I'm looking for, x. So now x ends up in that denominator. So remember, when that happens, you need to switch these two out. So when I switch those two out, I end up with what? X equals 50 over tangent of 42. So next I'm going to go to the calculator and I'm going to have to do 50 divided by tangent of 42 and see what that is. So let's see, 50 divided by tangent of 42. And if I hit enter on that, that gives me 55.5. That's easy to remember. 55.5. So that means x is going to equal, and that's how far the helicopter is from the car on the ground. So 55.5. And again, that's in feet. So that's an example of an angle of depression problem. Again, the key thing to remember here is the alternate interior angles that are going to happen. Let's see if I have another example here. So here now I have Max. He's on top of this 650-foot tall building. He spots his friend on the ground who's 35 feet from the base of the building. What's the angle of depression? So I'm looking for the angle of depression here. So let's see. I need a tall building here. So let's use this. And tall building, something like this. And then I'll draw the ground. That's street level. I'll draw Max and his buddy. So Max is on top of the building now. He's up here. And then there's his buddy down on the ground. All right, so let's see. I got some dimensions here. It says Max is on top of 600, so this distance here is 650 feet. So 650 over here. So that's basically how high he is off the ground. So he's standing 35 feet from the base of the building. Base of the building's down here, and then the 35 feet would be this distance here. So 35 would be along that way. What is the angle of depression from Max? So again, in order to make an angle of depression, again, it needs to be made with a horizontal line. So again, a horizontal line I'll draw first. Angle of depression would be down to his buddy. Something like that. And again, I'm looking for the angle of depression now. So I am looking for this measurement right here. So at this point, I'm looking for a triangle, and I see a right angle here. So the triangle I'm going to use is I'm going to use this leg over here at 650, this leg here at 35, and here's my hypotenuse. Now this angle here, remember, is alternate interior with the angle of elevation down here. So I'm just going to put the X in there. So now I got to go to SOHCAHTOA, try to figure out what's going on here. So here's my angle that I'm looking for. This is opposite that angle. This is adjacent, so again I'll be using TOA. So TOA. And T stands for tangent. So it'll be tangent of the angle, which I don't know, X, is going to equal now the opposite side over the adjacent. So the opposite side is 650. That's a 650 divided by the adjacent side, 35. So now I'm looking for an angle. So in order to do that on the calculator, remember you have to hit the second button. So 650 over 35. So I got to go second tangent, and I got to put in the ratio 650 over 35. And I end up with a tangent ratio of 86.9 degrees. So that's my degree measure, 86.9 degrees. So it'd say X is equal to 86.9, and again that's in degrees. So we'll put that little degree symbol up here. So that's the way of finding an angle. So again, they had to set that up using the same methods, but then we had to hit the second button on the calculator to use degrees on that. So let's see, undo that. So tonight's homework, you'll be doing that same thing. You'll be using the angle of depression now instead of the angle of elevation when you're looking for a side. Again, you don't have to hit the second button. If you're looking for an angle of depression itself, then you're going to have to use that second button. Also keep in mind you're going to have these alternate interior angles, which is going to help you come up with your triangle when you're trying to figure out these problems. So again, I'm going to put the homework you'll find in the folder in the PDF form. I want you to work on that, then submit your work through that. And good luck, and email me if you have any questions. Thank you very much. And